The second chapter of Statistics and Probability deals with data presentation. In this video, we shall discuss and illustrate presentation of data using text, tables, and graphs. Textual presentation makes use of words, phrases, sentences, and paragraphs to explain and describe data. In textual presentation, important values and observations must be highlighted. It also provides us with explanations about summary measures like the mean, standard deviations, and etc. For large mass of quantitative or numerical data, a table presentation is necessary. In this type of presentation, frequencies, relative frequencies, and percentages for each category or interval must be shown. Also, column and row headings as well as important totals and subtotals must also be observed. In this illustration, working in private companies and federal government obtain the highest and lowest frequencies, and they are highlighted in the textual presentation above the table. For added explanation, the researcher may include possible causes or reasons that led to those results. For table presentations, the most common is the frequency distribution table. It often shows categories of qualitative data or intervals of quantitative data with their corresponding frequencies, relative frequency, and percentage. It is a way of transforming raw data into grouped data. This is an example of a table presentation for the qualitative variable type of employment. On the other hand, this is an example of a frequency distribution for quantitative data as evident from the class interval in the first column. These are the steps in constructing a frequency distribution table for qualitative data. First, you need to list down all the categories and count the responses corresponding to each category to determine the frequency. Next, determine the relative frequency by dividing each frequency by the total number of responses. Lastly, compute the percentage by multiplying each relative frequency by 100. For example, consider the raw data about possible mode of transportation in the first table. In the first column of the second table, we see all the distinct categories, and the second column shows the number of responses in the raw data that would fall under a specific category. Lastly, the last two columns provide the relative frequency and percentage. Now let us have an example of constructing a frequency distribution for quantitative data by considering the raw data on your screen. Let us construct a frequency table that would consist of 5 class intervals. The first step is to compute the range of values by subtracting the lowest value in the dataset from the highest value. In our example, it is 378 minus 115 equals 263. The second step is to determine the class width. This is obtained by dividing the range by the desired number of class intervals. However, this class width should have the same precision as the most precise value in the dataset. For example, if the most precise value in the dataset contains one decimal place or in the nearest tenths, then the class width should be rounded down to the nearest tenths. In our illustration, the class width is the range, which is 263 divided by the desired 5 class intervals. This gives us 52.6. However, since the values in the given dataset for this example are all whole numbers, then the class width 52.6 should be rounded down to 52, which is also a whole number. The next step is to construct a table with 5 columns containing the following headings: class limit or class interval, class boundary, frequency, relative frequency, and percentage frequency. Then we completely fill in the class limit or class interval column. The lowest value in the dataset shall serve as the first lower limit. To get the upper limit of the first interval, we add the rounded down value of the class width. Now, the second lower limit is the next number following the upper limit of the previous interval. Then, we add again the rounded down value of the class width to get the second upper limit. This process continues until we complete all the class limits or class intervals. In our example, the lowest value in the dataset is 115, and the rounded down value of the class width is 52. Adding 52 to 115, we get 167, which is the upper limit of the first interval. For the next interval, we use the next number 168 and add 52 again to get the upper limit, which is 220. The process continues until we have reached the fifth and last interval. After completing the first column of the table, we next complete the class boundary column. To complete the class boundary column, we follow step number 6. Applying step number 6 to our example, we subtract the upper class limit 167 of the first interval from the lower class limit 168 of the second interval, and then divide the difference 168 minus 167 by 2. This gives us 0.5. This number 0.5 must be subtracted from all the lower limits to obtain all the lower class boundaries. So we have 115 minus zero point 0.5 equals 114.5. 168 minus zero point 0.5 equals 167.5, and so on. The same number zero point 0.5 must be added to all the upper limits to get all the upper class boundaries. In our example again, we have 167 plus zero point 0.5 equals 167.5, 220 plus zero point 0.5 equals 220.5, and so on and so forth. The next step is to complete the frequency column by counting the number of values in the raw data that would fall in the intervals, inclusive of the limits. After that, complete the relative frequency columns and the percentage columns. The formulas for these are similar as in the frequency distribution for qualitative data. Now you can try doing this particular example. Then, verify your answer by looking at this table on your screen. If there is a correction, please notify me. Now, in the next video, graphical presentation shall be illustrated.